Hi everyone, for today's lesson, we are going to learn how to apply the remainder and factor theorems. Now, the I can statements for today is for you to be able to say, I can divide polynomial expressions using long division and synthetic division. Now, notice that we're using the word remainder. When you guys learned about remainders, you were probably in elementary school and you learned about long division, and we would end up with a remainder, and we would put a little r at the end, or we would turn that remainder into a fraction, and that's exactly what we are going to be using, old-fashioned long division. Notice that I also have this word synthetic division. We talked about the word synthetic before in this unit. That was when we were doing synthetic substitution, and now we're going to be using that skill to do a thing called synthetic division. So in polynomials, we are allowed to add, subtract, and multiply them, but now we are also going to be able to divide them. So our warm-up for today is to remind ourselves how to use long division. So I'm going to try to make this as clear as I can. I appreciate your patience. There we go. So in long division, we have 2,345 divided by 8. And what we do is we put 8 on the outside. This is called the divisor. And then on the inside of the box, we're going to have what we call our dividend. So I'm going to write 2,345. To start this problem, we would look at 8 going into 2. Can 8 go into 2 evenly? No. So then we move on to the next one. Can 8 go into 23? Yeah, it can. How many times? 8 can go into, without going over, it can go into 23 2 times. So I'm going to line up 2 with the number 3 because I skipped the first 2 and I'm on now the next digit. So 2 times 8 is 16, and I am going to now subtract. So 23 minus 16, that's equal to 7. And now I'm ready to bring down my next digit, which is 4. And I have to ask myself, how many times can 8 go into 74 evenly? And hopefully you're able to say 9 times. 9 times 8 is 72. And now I'm going to subtract 74 minus 72. That is equal to 2. And now I'm ready to bring down my very last digit, which is 5. And I'm going to ask myself again, how many times can 8 go into 25? And this time around, it is 3. So 3 times 8 is 24. And I'm going to subtract. And when I do that, I end up with 1. There's nothing more for me to bring down, so this 1 represents the word remainder. And we would normally write this as 293 remainder 1. In reality, this means how we use this remainder is we write this as 293 and 1/8, which is like a little plus sign right here. So 293 and 1/8. So where this comes from is it's always going to be our remainder divided by our divisor. That's the number that we divided on the outside, the remainder over the divisor. There exists an invisible plus sign that is going to be in between these numbers. Now that invisible plus sign, we are actually going to be putting it in whenever we are working with polynomials. So I want you guys to keep in mind. But these steps that I just talked about are as follows. The first step that we did is called Dad, Mom, Sister, Brother, Rover. So here's Dad. Dad was, we would divide. We asked ourselves, how many times can 8 go into 23? We divided. 23 divided by 8 gave us 2 point something, and so therefore we would put 2 up above. Mom is called multiply. We would multiply 2 times 8, and that gave us 16. Sister sister comes next. Sister is subtract. 23 minus 16 gave us 7. Next is brother. So dad, mom, sister, brother. Brother means bring down. We brought down our next number, which was 4. And then R represents rover, which is repeat the process. Rover, I guess, is supposed to be the dog in this situation. We call it repeat. So we brought down the 4, and then we repeated the process. How many times can 8 go into 74 or divide into it? 9 times. 9 times 8, multiply, gave us 72. Subtract, sister, 74 minus 72 gave us 2. And then we brought down the next number and repeated the process. All the way up until we ended with nothing more to bring down, and we finished the process with a remainder. And when we wrote our answer, 293 and an eighth, there exists an invisible plus sign, and we are going to use this now with polynomial long division. So just like when we were working with synthetic substitution, we needed to make sure that every degree was represented, and I need you guys to do the same exact thing. Polynomial long division is set up the exact same way as our warm-up. We just need to make sure that we include every exponent. So what that means is, just like before, we need to make sure that every degree must be represented. You might need to insert like an x or 0x squared or whatever it is that's missing. You need to make sure it's represented. Please know that long division always works. Synthetic division only, which you guys are going to love, but synthetic division only works sometimes for very specific cases. So just keep that in mind. Let's look at example number 1. For example number 1, I need to make sure that every degree is represented. So I have a 3, a 2, and a 0. So what I'm missing is my linear term. So I'm going to rewrite this as x cubed plus 3x squared plus 0x minus 7. And this is being divided by x squared minus x minus 2. All of my degrees are represented in my divisor, and now all of my degrees are represented in my dividend. So I'm going to put x squared minus x minus 2 on the outside of a box. And underneath my box, I'm going to write x cubed plus 3x squared plus 0x minus 7. I cannot emphasize enough making sure you are neat when you are using long division. You will get lost if you have sloppy handwriting. So if you know that you might have not the neatest of handwriting, please, please, please be very, very slow and intentional with how you write everything down. So I am going to start with my first term on the outside and my first term on the inside. I am only looking at the very, very first terms. That's it. And I'm going to ask myself, what times x squared equals x to the third power? So what times x squared equals x cubed? That is x. And I'm going to put x over my x term. And now I'm going to multiply. X times x squared is x cubed. And I'm going to multiply this x by all of the terms in my divisor. So x times x squared is x cubed. X times minus x is minus x squared. And x times negative 2 is minus 2x. Now, my next step is to subtract. Now, whenever you subtract, you have to change all of the signs to their opposite. So I am going to subtract x cubed, but I also am subtracting, so minusing a negative makes that a plus. Minus a negative makes this a plus. Whenever you subtract, you're going to do the opposite sign. So right here, I need you guys to know that we are going to change all signs to their opposite. and then we're going to combine. So x cubed minus x cubed cancel away. 3x squared plus x squared is 4x squared. 0x plus 2x is plus 2x. And now I'm going to bring down the minus 7 and repeat the process. You always want the terms, the first terms, to cancel away. That's how you know you did it correctly. And I'm going to repeat. My focus once again is on x squared and 4x squared. So it's just the first term and the first term. And I ask myself, what times x squared equals 4x squared? That is a positive 4. And I line up the positive 4 with my constant term. 4 times x squared is 4x squared. 4 times negative x is minus 4x. 4 times negative 2 is minus 8. And now, just like before, I need to change all of my signs to their opposite and combine. Four x squared minus 4x squared cancels away. This leaves me with 2x plus 4x, which is 6x, and negative 7 plus 8 is plus 1. There is nothing more to bring down, so therefore 6x plus 1 represents my remainder. So therefore my final answer is x plus 4 plus my remainder, which is 6x plus 1, divided by my divisor, which is x squared minus x minus 2. And that is my full answer. So once again, where this comes from is it comes from up here when I had my remainder over my divisor. Remember, 8 was the number that's on the outside. And 293 and an eighth has an invisible plus sign that we are actually going to see whenever we write down our answers for polynomial long division. Let's go ahead and do example number 2 on our own. But again, so that you guys can see this again. This is our answer, but I also need to emphasize once again that you must have a plus sign between what you get your answer to be and the remainder. Remember that the numerator is your remainder and the denominator is your divisor. This is the answer to your problem. So now let's go ahead and look at example number 2. For example number 2, we want to make sure that every degree is represented. I see 4, 3, 1, 0. I see 2, 1, 0. So making sure that every degree is represented, I'm going to need to insert a 0 in the x squared position. 2x to the 4th plus x cubed plus 0x squared plus x minus 1 divided by x squared plus 2x minus 1. So once again, in both parentheses, you need all of your degrees to be represented. I am going to put x squared plus 2x minus 1 on the outside, and underneath the box, I'm going to put 2x to the 4th power plus x cubed plus 0x squared plus x minus 1. And now I'm going to ask myself, what times x squared equals 2x to the 4th power? Because it's all about the first term with the first term. And that is going to be 2x squared. So I am going to line up whatever my degree is with my like degrees. That's why it's very important for you to be very neat. And I'm going to multiply. 2x squared times x squared is 2x to the 4th power. 2x squared times 2x, that is 4x to the 3rd power. And 2x squared times minus 1 is minus 2x squared. I am now going to change all of the signs to their opposite and combine going straight down. 2x to the 4th minus 2x to the 4th cancels away. X cubed minus 4x cubed is negative 3x cubed. 0x squared plus 2x squared is plus 2x squared. And now I'm going to bring down the plus x and repeat the process. I always look at my first term and my first term. What times x squared equals negative 3x cubed? That is going to be minus 3x. So now I'm going to multiply. Negative 3x times x squared is negative 3x cubed. Negative 3x times 2x is minus 6x squared. Negative 3x times negative 1 is positive 3x. I am now going to change all of my signs to their opposite. This becomes a plus, and a minus. I always use a different color because it helps me to see where I'm at in the process. Negative 3x cubed plus 3x cubed cancels away. 2x squared plus 6x squared is 8x squared. X minus 3 is minus 2x, and now I'm bringing down my last term. And I'm going to repeat the process, focusing on the first term and the first term. And I ask myself, what times x squared equals 8x squared? And that's going to be a positive 8. So now I'm going to multiply. 8 times x squared is 8x squared. 8 times 2x is a positive 16x. 8 times negative 1 is negative 8. So now I'm going to change all of my signs to their opposite, and I'm going to combine going straight down. 8x squared minus 8x squared cancels away. Negative 2x minus 16x is negative 18x. Negative 1 plus 8 is plus 7. There is nothing more to bring down, so here is my remainder. So my final answer is the polynomial that I have up top, which is going to be 2x squared minus 3x plus 8, plus my remainder, which is negative 18x plus 7, divided by my divisor, which is x squared plus 2x minus 1. And this whole craziness is my answer. So now I'm going to ask you a bonus question. So my bonus question for you is down here, and it says, are the answers for example 1 and example 2 polynomials? Explain. So pause this video. Are these polynomials? Think about it. They have polynomial pieces, but are they polynomials themselves? And the answer in this case is no. And that's because we end up with exponents in the denominator. And so therefore, no, these two answers are not polynomials because all of the exponents are not whole numbers. Let's go ahead and move on to the next page. So that was long division, and now we're going to talk about synthetic division. So synthetic division can be used to divide any polynomial by a divisor if that divisor is in the form of x minus k. So it has to be a binomial, not just a binomial, a linear binomial. So if you're dividing by a linear binomial, that is the only time when you're allowed to use synthetic division. So we'll use the same format as synthetic substitution, but instead of focusing only on the last number like we did when we were working with synthetic substitution, all of the values below the line are going to be used. Now those values that end up being below the line, they give us the coefficients of the quotient that will be 1 degree less than the dividend. So that means that if you're dividing an x cubed, the answer below the line will be x squared. If this was an x to the 5th, the values below the line will start off with x to the 4th, and so on. The last number is important because it represents the remainder, and we will put it over the divisor. So this is how synthetic division works. First of all, we are going to be working the remainder theorem. This goes along with the remainder theorem. And the remainder theorem says that if a polynomial f of x is divided by x minus k, which is a linear binomial, then the remainder is f of k. So what that means is that I'm going to be dividing by a linear binomial. And the number that is going to go on the inside is going to be, if we were to set x minus 3 equal to 0, what would x equal if you solved for x? X would equal 3. So it would be the opposite of what we see on the inside. So what I'm going to do is I'm going to substitute 3, or put 3 inside of the little box. So that comes from my linear binomial. 3 goes inside of the little box. And I need to make sure, once again, that every degree is represented. So I'm going to write that every degree must be represented. So that's really, really important. Every degree must be represented. And fortunately, 3, 2, 1, 0, every degree is in this problem. So I'm going to put 3 inside of the little box, and I'm going to write 2, 9, 14, and 5. Make sure that this doesn't look like 2,914. You really don't want the number. You want to have some space in between the numbers. And in between your last two values, we're going to put a vertical line and then a horizontal line. Remember that we add above and multiply below, bringing down our very first number, which is 2. And I'm going to multiply 3 times 2, which is 6. 9 plus 6 is 15. And I'm going to repeat. 3 times 15 is 45. 14 plus 45 is 59. 3 times 59, you might need a calculator, but that equals 177. And 5 plus 177 is 182. So how are we going to use these numbers? Well, we're going to write a polynomial that is 1 degree less than what we started with. And what we started with is a cubic. So therefore, we're going to work with 1 degree less. That's going to be 2x squared plus 15x plus 59 plus what 182 represents is it represents the remainder. And we write that as our remainder over our divisor. So that's going to be 182 divided by x minus 3. And there is our answer. Let's go ahead and look at example number 4. For example number 4, we need to make sure that every degree is represented. And I have a 3, a 2, and a 0. So I am missing some terms. So I'm going to write down that we have x to the third minus x squared plus 0x minus 10. And this is going to be divided by x plus 2. So you have to ask yourself, if I wanted to find what the 0 was, this is going to produce x equals negative 2. It's the opposite of what I see on the inside. And so negative 2 is going to go inside of the little box. And I'm going to write 1, negative 1, 0, negative 10. And I'm going to draw a vertical line and a horizontal line, bringing down my very first number, which is 1. Negative 2 times 1 is negative 2. Negative 1 minus 2 is negative 3. Negative 2 times negative 3 is positive 6. 0 plus 6 is 6. Negative 2 times 6 is negative 12. And negative 10 plus negative 12 is negative 22. What's below the line is going to be 1 degree less than what we started with. So since we started with a cubic, I'm going to start with x squared. 1x squared minus 3x plus 6 plus, here's my remainder. That is going to be negative 22 divided by my divisor, which is x plus 2. And there is my full answer. We have 2 solo questions that I would like you guys to please try on your own. And now we also have a pair question. So in this problem, for the pair, I want you to decide, looking at this problem, which method, long division or synthetic division, should you use in this problem and answer why. And then after you have figured out which method is the most appropriate, I want you to find the quotient. So it's very important that you find that quotient. And I will go through all of these problems the next time that I